Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Welcome to PMDC online lecture room. Dear students, today our topic of discussion is significant figures. What are significant figures? Anytime we take measurement, there is a level of some uncertainty because no measurement can be exactly 100%. Significant figures are all the digits which we know with certainty and the first uncertain digit. In any measurement, the number of accurately known digit and the first doubtful digit are called significant figure. Or we can also say that the number of digits with certainty and the first uncertain digit are called significant figure. Doubtful digit or uncertain digit are those digits that come after the decimal point. Here are some rules to find out the significant figures. Rule number 1 is all non-zero digits from 1 to 9 are significant. For example, here in this example, 45.678. These 5 digits comes between 1 to 9. So these 5 digits are significant. Rule number 2 is 0 between two non-zero digits are significant, which means if any zero lie between two non-zero digits, then those zeros should be considered to be significant. In this case, these two zero lies between 4 and 7. So here these two zeros should be considered as significant figure. So in this case, the number of significant figures are 1, 2, 3, 4 and 5. Rule number 3 is if the zero lie to the right of the decimal and the same zero lie to the left of the non-zero digit, then those zeros are considered to be non-significant, which means then those zeros should not be considered as significant. Here in this example, these three zeros lie right to the decimal point and these zeros lie left to the non-zero digit, which are 9 and 8. So in this case, these zeros should not be considered to be significant. Only the number of significant figures are 2, which is 9 and 8. Rule number 4 is if the zero lie to the right of the decimal and that decimal appears after the non-zero digit, then the zeros are considered to be significant. Here I have taken an example 13.0000. These zeros lie to the right of the decimal point and this decimal point appear after the non-zero digit. So these zeros should be considered to be significant. In this case, the number of significant figures are 1, 2, 3, 4, 5 and 6. If you have an integer number like here I have taken an example of 40,000 kgs. Here we don't know where the decimal point is. So we don't know the significance of these zeros. To find out the significance of these zeros, we will use the least count of measuring instrument. Let's say if the least count of the measuring instrument is 10, then we will divide this integer number 40,000 by 10. We will left with 4,000 and then writing that 4,000 in scientific notation, we will get the term 4.000 multiplied by 10 raised to power 3. So here you can see that these three zero lie to the right of the decimal point and the decimal appear after the non-zero digit. So these zeros should be considered to be significant. Here number of significant figures are 1, 2, 3 and 4. In scientific notation or in standard form, the figures other than the power of 10 are significant figures, which means that you will not include 10 and the power of 10 to be as significant figure. Here in this example 5.67 multiplied by 10 raised to power 4. The number of significant figure are 5, 6 and 7. We will not include this term 10 raised to power 4 in the significant figure. In addition and subtraction, the result obtained from the measurement is retained to the measurement which is least precise in the data. Here I have taken an example. Let's say the distance traveled by the boy in first 3 rounds are x1 is equals to 13.5 meter, x2 is equals to 14.18 meter. So if you are going to add them, the result should be retained to the least precise one in the data. Here in the data the least precise value is 13.5. Why it is least precise? Because here there is one digit after the decimal point. So we will round off our result to be one digit after the decimal point. When we add them together, x is equals to x1 plus x2, we will get 27.68 meter. As in data, the reading 13.5 is least precise. Thus, we round off our final result to a single digit after the decimal point. So, 27.68 meter will be 27.7 meter. If you are going to multiply or divide, then the final result is limited to the number containing the least number of significant figure. In data, if any quantity has least number of significant figure, you will round off your result to be that number of significant figure. In this example, x1 is equals to 4.6 centimeter and x2 is equals to 5.678 centimeter. Here you can see that x1 is having 2 significant figure, x2 is having 4 significant figure. So the least number of significant figure is 2. We will round off our result to be significant figure of number 2. So x1 multiplied by x2, the result will be 26.1188 centimeter square. Here the number of significant figures are 1, 2, 3, 4, 5, 6. So we will round off our result to 2 significant figure. So I have done that over here. 26.1188 centimeter square will be 26.119 centimeter square is equals to 26.12 centimeter square, which is equals to 26.2 centimeter square. Here you can see that this result is least precise, but it is having 3 number of significant figures, 1, 2 and 3. But in our data, the least number of significant figure is 2. So we will round off our result and we will get x is equals to 26 centimeter per centimeter square. Here you can see the number of significant figures are 2, 1 and 2. Now your task is to find out the result by dividing m1 by m2 and round off your result by least significant figure. Thank you so much.